Inverse of matrices. What is the inverse of a matrix, of a matrix whose order is a 2 by 2? For example, we have a matrix B, which is 1 and 1, then 1 and 2. The inverse of matrix B can be found by method 1. Method 1 can be found by 1 over the determinant of B, then multiplied by the adjoint of B. Then determinant B equals to multiplying the elements on this leading diagonal, this one, then subtracting from these elements on the principal diagonal. That is 1 multiplied by 2, then minus 1 multiplied by 1, which is 2 minus 1 multiplied by 1 is 1, then is 1. Then determinant B, denoted as B, then that way equals to 1. What is the adjoint? Because we need to find the adjoint. The adjoint B. Adjoint of B. Let us make our A something visible. Adjoint of B equals to the transpose of the cofactors of B. The transpose. You know that the transpose is not a T at the upper side. Then the cofactors of a 2 by 2 matrix, of a matrix whose order is a 2 by 2, we swap the elements on the leading diagonal. If our matrix is 1, a matrix B 1, 1 and 1 over 2, then the transpose, we swap this and this. It gets to be 2 and 1. We interchange that one. Then this one and this one changes the sign. The sign changes. So actually this is the adjoint. But remember, adjoint B, we are not told to find the adjoint. We are told to find the inverse of B. The inverse, as we said, equals to 1 over determinant B, then multiplied by adjoint B. What is our determinant? 1 over 1. We found our determinant as 1. Then what is our adjoint? This one, adjoint B, is the transpose of the cofactors. What is the transpose of our cofactors? Our transpose is 2, this one. So equals to 2, -1, -1 and 1, which is okay. 1 doesn't seem to bring any change there, so we have 2, -1, -1 and 1 to be the inverse. B inverse, denoted as we have some dash on top of B to denote the inverse. This is the inverse of B. That is how to find the inverse of B. But what if we are trying to find the inverse of B using another method, method 2? Method 2 of finding the inverse of a 2 by 2 matrix, we can say we have our matrix B being 1, 1, 1 and 2, and we have to arrive at the same answer multiplied by the identity matrix. Then we have to expand this to this side, then we'll be having our inverse. Then we use the row echelon form, to reduce that one to the other side. Then we will be having, that is, we want to take this one to 0. Then we will take row 2. It will be row 2. Operation on row 2, which is row 2 minus row 1. Row 2 minus row 1. This row 2 minus row 1 will be row 2 minus row 1. 1 minus 1 is 0. Then the elements on row 1 remain intact. Remember that elements on row 1 remain intact. Then row 2 minus row 1, that is 1 minus 1. 1 minus 1 is 0. Then 2 minus 1 is 1. Then we have 0 minus 1 is negative 1. This is a break. Okay, temporal break in between the identity matrix and the matrix on operation. Then we'll be having 1 multiplied by subtracted 0 is 1. Then we shall be having this one. We have to do it further so that we done this one. We want to make this one. We want to make matrix B into identity matrix, into an identity of this type. Then what will we do? What we will do to 1? We have to make it 0, and we will take row operation on row 1, which will be row 1 minus, row 2. Operation on row 1, operation on row 1, which will be row 1 minus row 2, will be row 1, this one, minus row 2. This minus this will be negative. This minus this will be 1. Then elements on this, on the second row, will remain intact as we make some computation on row 1. Then row 1 minus row 2 is 0. Of course, we have achieved what we wanted. We wanted this matrix to turn into an identity matrix of this type. Then we'll go to 1 minus 1. 1 minus minus 1. Then it will be, that is 2, because 1 minus minus 1 is 2. So we reduce using the echelon form. So row 1 operation on row 1, that's row 1 minus row 2. Then row 1 minus row 2 on this one, row 1, this is 0 minus 1 is negative 1. Then we will have arrived at the same answer. So the inverse of B inverse is this one, is this matrix, which is negative. This is 2, negative 1, negative 1, and 1. We can see that either using the first method or this second method by reducing it using the identity matrix, using the row echelon form of reducing that matrix, we arrive at the same inverse as the inverse that we found on this upper side. This one is similar. So it is upon you to choose which method that suits you in making or finding the inverse of that matrix. Okay.